Magandang araw mga kainhinyerong sibil. Ako ang inyong guro, Daryl J. Mendros Balbin. In this video, I will solve the second sample problem in pipe connections and reservoirs. Two reservoirs have 6-meter difference in water levels and are connected by a pipe 60 centimeters in diameter and 3 kilometers long. Then the pipe branches into two pipes, each 30 centimeters in diameter and 1.5 kilometer long. If the friction coefficient is equal to 0.01, determine the flow rates in the pipe system, neglecting minor losses. Using Bernoulli's equation, we can see that the head loss due to friction is equivalent to the head loss due to elevation. So let's try to establish or prove this statement. Writing the Bernoulli's equation from point 1 to point 2, wherein point 1 is the water surface at reservoir 1 and point 2 is the water surface at reservoir 2, the resulting equation is this one. Substituting the values, since both reservoirs 1 and 2 are open to the atmosphere, both their pressures and velocities are equal to 0. For the elevation of point 1 with respect to point 2, that is equal to 6 meters. And for the elevation of point 2 with respect to point 2 is of course equal to 0. And now we can solve for HF. HF is equal to 6 meters. Now since pipe 1 is in series with pipe 2, we can say that the sum of their head loss is equal to the total head loss 6 meters. That is, HF1 plus HF2 is equal to 6 meters. For HF, since we were given F, we will be using Darcy-Weisbach formula. So we have 0.826 FL1 Q1 squared over D1 raised to 5 plus 0.826 FL2 Q2 squared over D2 raised to 5 is equal to 6 meters. Substituting the values further, based on the problem, F is equal to 0.01. L1 is 3,000 meters. D1 is 0.6 meter. Q1 is unknown. L2 is 1,500 meters. D2 is 0.3 meter. Q2 is unknown. Now, since pipe 1 branches into pipes 2 and 3, we can say that Q1 is equal to Q2 plus Q3. But pipe 2 is in parallel connection with pipe 3. Therefore, head loss in pipe 2 is equal to head loss in pipe 3. And if their head losses are equal and they are identical pipes, Q2 is also equal to Q3. And if Q2 is equal to Q3, then Q1 is equal to twice Q2. Returning to the head loss formula or equation, we simply substitute Q1 with 2Q2. We can see now that in this equation, there is only one unknown, and that is Q2. Therefore, we can solve for Q2. And Q2 is equal to 0.97 cubic meter per second or 97 liters per second. Solving for Q1 and Q3, for Q3, that is simply equal to Q2, which is equal to 97 liters per second. And finally, for Q1, that is equal to twice Q2, and substituting, Q1 is equal to 194 liters per second.